Welcome to this custom tailored deep dive. We're so glad you're joining us today, especially if you're the kind of person who, just loves having the inside scoop on how everyday items actually work.
Yeah, those invisible processes all around us.
Exactly. I mean, think about that moment when you're standing in a store looking at a massive shelf full of skincare products, and you just wonder, how did any of this actually get here?
Right.
Like, what does it really take to get a specific moisturizer with all those bold scientific claims on the front out of a laboratory and directly into your hands?
Well, it is a surprisingly massive journey. Modern cosmetics they've evolved so far beyond that old vintage image of someone simply mixing lotions in a glass beaker.
Right, the mad scientist aesthetic.
Exactly.
Yeah.
Today, developing a consumer product is a highly rigorous, incredibly high-tech discipline. It sits right at this crazy intersection of strict global regulations, cutting-edge green chemistry, and, believe it or not, artificial intelligence.
Which sounds like science fiction, but it's happening right now. And to shortcut your path to understanding all of this, we are pulling from a really fascinating source today.
It's a great comprehensive guide.
It is. We are looking at a March 2026 guide titled Cosmetic Formulation Development by Ingredientsage, which was founded by Laurent Fabian. And our mission for this deep dive is to map out that entire end-to-end workflow.
The whole process.
Yeah, from the initial safety assessments and physical torture testing, all the way to factory scale-up and sustainable packaging. Okay, let's unpack this, starting with the rules of the game. Because the regulatory rulebook has undergone a pretty massive shift recently.
Oh, the landscape has fundamentally changed. I mean, the source details some major developments that took place right between 2023 and 2025. Regulators across the globe they accelerated this push for extreme transparency.
Like digital product passports, right?
Exactly. We are seeing the introduction of digital product passports and enhanced traceability pilots. And this is a real paradigm shift for the industry because the ultimate goal is to drastically improve the flow of information.
Right, from the factory floor to the bathroom sink.
Yes, from the very origin of the supply chain down to you, the consumer. If a brand makes a claim online today, regulators are now demanding robust, totally accessible data trails to back it up.
So it's no longer just about the physical liquid in the bottle. It's about having a verifiable digital trail for every single drop of that liquid.
Precisely.
And at the center of all that documentation is something the guide refers to as the CPSR, right?
The Cosmetic Product Safety Report.
Right.
Because safety is the absolute non-negotiable foundation of this entire process. A formal safety assessment like the CPSR, it documents the complete risk profile of the formulation.
And the detail is kind of wild.
The meticulous nature of it is staggering. Toxicologists don't just look at ingredients in isolation. They calculate daily exposure based on highly specific usage scenarios.
Like how much lotion you actually rub on your arm.
Yeah, they look at the exact surface area of the skin the product is applied to. Whether it's a rinse-off product like face wash or a leave-on product like a serum, the frequency of use, and then they estimate the exact chemical exposure levels.
But wait, what happens if they simply do not have historical safety data for something, like a specific, newly discovered botanical ingredient?
That happens quite a bit, actually.
Especially if that product is eventually meant for a vulnerable group, like children or people with compromised skin barriers. Do they just, make an educated guess?
Well, they don't just guess, but they do use predictive modeling. When data gaps exist, modern science relies on what are called in silico methods.
Wait, in silico?
Yeah, specifically QSR and read-across approaches.
In silico, as in inside a silicon computer chip. We're just letting a computer guess if a new ingredient is safe for a baby. Because that sounds incredibly risky.
I completely understand why that sounds concerning, but it is actually a highly conservative, mathematically rigorous process. QSR stands for Quantitative Structure-Activity Relationship.
Okay, that's a mouthful.
It is, but essentially, the computer models look at the molecular structure of the new ingredient. If its shape and its chemical bonds are nearly identical to an ingredient we already have, say, 50 years of safety data on.
Oh, I see.
The system can predict how it will behave in the human body based on that structural match. And for those vulnerable populations, formulators are required to adopt the most conservative exposure assumptions possible.
So they assume the absolute worst-case scenario.
Exactly. They pad the numbers with massive safety margins and include explicit risk disclosures.
That makes a lot more sense. It's structural matching rather than just blind guessing, which actually brings up a great example from the text regarding those explicit disclosures, which is allergens.
Oh, the allergen rules are intense.
Yeah, the EU fragrance allergen rules are incredibly strict, and they kind of serve as a global benchmark for compliance. If a product contains even trace amounts of specific compounds known to cause reactions, they must be listed clearly.
No hiding behind generic terms like fragrance.
Right. So when you buy a product specifically marketed for sensitive skin, you are actually purchasing the result of a massive, highly documented trail of risk profiling.
It translates mountains of complex technical risk data into practical guidance.
Mhm.
Because you, the consumer, you don't need to read a 500-page toxicology report. You just need to trust the label to use the product safely.
All right, so we have the safety and regulatory foundation laid out. Let's move into the actual chemistry, the building blocks of the formula itself.
This is where it gets really hands-on.
Yeah, the text outlines some primary functional requirements. If you're making a cream or a lotion, you are essentially trying to force oil and water to mix, which they naturally absolutely hate doing.
They will separate immediately if left alone.
Right, so you need emulsifiers to act as the peacemaker between the two. And that could be an oil and water system or a water and oil system. You also need humectants to pull moisture into the skin, thickeners for the right texture, and sensorial enhancers.
And every single one of these ingredients has to use INCI naming.
INCI.
INCI stands for the International Nomenclature of Cosmetic Ingredients. It is a strictly standardized naming system. It basically ensures that a dermatologist in Tokyo, a factory worker in Paris, and a consumer in New York all know exactly what is in the bottle.
Which is why plain old water is always listed as aqua on the back of the bottle. Here's where it gets really interesting, though. Making a product that feels great and uses the proper INCI names is only half the battle.
Keeping it from spoiling is the other half.
Yes, keeping that product from spoiling on your warm, humid bathroom counter is a completely different challenge, and consumer demand has totally flipped how formulators handle preservatives today.
Consumers today are pushing so hard for clean labels, which often means stripping out traditional heavy-duty synthetic additives.
The parabens and things like that.
Exactly. But the undeniable reality is that a water-based product sitting in a warm bathroom is a perfect breeding ground for microbial growth. It still has to be completely safe. So formulators are getting highly creative, using what the guide calls a multi-hurdle defense.
I love this concept. Rather than just dumping a single harsh chemical into the vat to kill off everything, they're almost setting up an obstacle course for the bacteria.
That is a brilliant way to picture it, honestly. Instead of relying on one massive roadblock, they set up a series of smaller hurdles that microorganisms simply cannot jump over collectively.
Like what kind of hurdles?
Well, this might include using safer, nature-derived preservatives combined with really strict pH management. Bacteria really struggle to grow in highly acidic or highly alkaline environments.
Right, they want a neutral playing field.
Exactly. They also rely on advanced packaging hurdles, like airless pumps, that physically prevent contaminated air or dirty fingers from ever touching the lotion inside the bottle.
That makes total sense.
But the real challenge is validating that this entire obstacle course actually holds up under real-world conditions over time.
Which perfectly transitions us to the next phase, the torture testing.
It really is torture.
The text formally calls this stability testing, but reading the protocols, it's a total gauntlet. Brands cannot wait 2 years to see if a new face cream goes bad. So they use accelerated aging.
Accelerated aging relies on basic chemical principles. Heat speeds up reactions. The guide mentions baking products in environmental chambers at elevated temperatures and high humidity.
What's the standard for that?
A standard protocol is 40 degrees Celsius at 75% relative humidity.
Wow, so essentially a tropical rainforest.
Yeah, exactly. The goal is to simulate years of shelf life in a matter of months. And they are watching for phase separation, which is when the emulsifier fails and the product splits into an ugly layer of oil floating on top of the water.
Gross.
Yeah, it's not a good look. They're also looking for rheology changes, meaning the texture degrades from a nice thick cream into a runny, watery liquid.
And it's not just the physical texture they're worried about during this time. They have to ensure that multi-hurdle obstacle course we just talked about actually keeps the bacteria out as the product ages in that heat.
Right.
The source notes a specific global standard for this called ISO 11930. This is the rigorous protocol for preservative efficacy testing.
The sheer level of analytical rigor applied during this quality control phase is just staggering. The text introduces a veritable alphabet soup of high-tech machinery. Formulators use HPLC, LCMS, GC, and ICP-MS to analyze the formulation down to the molecular level.
Okay, let's translate that alphabet soup for the listener because the guide throws those acronyms out pretty rapidly.
Sure, let's break them down. HPLC stands for High Performance Liquid Chromatography. Think of it as a microscopic sorting facility. It separates every single component in a liquid mixture to ensure that the exact right amount of an active ingredient,
Like vitamin C or something.
exactly like vitamin C, is actually present in the final mix. Then LCMS takes that a step further by adding mass spectrometry, which essentially weighs the individual molecules to confirm their exact identity.
Okay, and then GC is gas chromatography, which the text mentions is used for measuring volatile components. I imagine that's crucial for things that evaporate quickly, like fragrances or essential oils.
Correct. It vaporizes the sample to analyze those lighter compounds. Finally, ICP-MS is inductively coupled plasma mass spectrometry.
That sounds intense.
It is. Think of this one as the ultimate metal detector. It can detect trace levels of heavy metals like lead or arsenic down to parts per trillion, ensuring the raw materials are completely pure.
That is a phenomenal amount of analytical firepower. But the text makes a crucial point here. Having all these million-dollar machines is utterly useless without rock-solid data integrity.
Data integrity is the backbone of this whole operation. All of this testing relies on a robust LIMS, a laboratory information management system.
Which is basically a giant database.
It's an unbreakable digital vault. A LIMS ensures absolute traceability across different facilities and different product lots. It utilizes highly secure audit trails.
So nobody can just change the numbers if a test fails.
Exactly. So that if a consumer reports an issue 2 years later, the brand can trace that exact bottle back to the specific machine that tested it and the exact employee who signed off on it.
Okay, so we have a formula that has survived the accelerated aging ovens and passed the high-tech QC sorting machines. But designing that perfect formula in a tiny lab beaker is a universe away from making 10,000 gallons of it in a factory. Let's dig into the data-driven approach to actually designing and scaling these formulas.
The guide highlights 2 critical frameworks that bridge the lab and the factory. DOE, which stands for Design of Experiments, and QBD, Quality by Design.
This is where it gets highly mathematical.
Yes, this is where formulation leaves the realm of trial and error art and becomes a highly statistical science. Instead of a chemist changing one variable at a time, like adding a little more thickener, testing it, and then adding a little more...
Which takes forever.
Right, they use DU. DOE uses statistical software to test multiple variables simultaneously. They map out how pH, the type of emulsifier, and the mixing speed all interact in a complex grid.
Finding the sweet spot?
Yes, by analyzing this grid, they find the perfect design space where the formulation will be completely stable no matter what minor fluctuations happen on the factory floor.
It takes the guesswork completely out of the equation. Dr. Michael Chen, a QA and regulatory lead quoted in the text, he perfectly captures why this is so critical. He says, a robust DOE-driven approach turns uncertainty into opportunity, helping teams deliver consistent quality at scale while meeting ever-tightened regulatory expectations.
And that's vital because the reality of scale-up is fraught with physical uncertainty. The jump from a pilot-scale lab bench to massive industrial vats introduces physics problems you just don't see in a beaker.
Like heat transfer.
Exactly. The source points out heat transfer as a major hurdle. Heating up a coffee cup-sized sample takes minutes, and it cools down just as fast. Heating up a 10,000-gallon vat changes the entire thermodynamic profile.
It holds the heat for hours.
Right. If it cools too slowly, the ingredients might literally overcook. You also have to contend with shear effects.
Shear effects being the physical violence of massive industrial mixing blades, basically tearing the delicate oil droplets apart, right?
Yeah.
Breaking the emulsion you just spend months designing.
Precisely. The physical force is immense. That's why pilot-scale studies are run to probe the robustness of the formula. And once full-scale manufacturing begins, the factory doesn't just cross its fingers. This is where PATKey comes into play.
Process analytical technology. Let me see if I can contextualize, Pat. Imagine you're trying to bake a cake, but you are only allowed to check if it tastes good after it has been in the oven for an hour. If you messed up the sugar ratio, the whole cake is ruined.
It's too late to fix it.
Right. PD is like having sensors that let you taste the batter, check the internal temperature, and measure the moisture constantly while it is baking without ever opening the oven door.
That is an excellent analogy. PD utilizes sensors right on the factory floor to check critical parameters like viscosity, turbidity, and pH inline or at line. They are constantly monitoring the product while it is moving through the pipes.
So they can catch a mistake instantly?
Yes, it detects deviations immediately, allowing operators to adjust the mixing speed or temperature on the fly without ever halting the production line.
So what does this all mean for the final step of the journey? The product is formulated, it's stable, it survived the giant mixing blades. Now it has to be packaged and marketed to you, and the text outlines a labeling labyrinth that brands have to navigate.
A labyrinth is putting it mildly. The rules vary wildly depending on where the product is sold. We already covered INCI naming and the EU's fragrance disclosures, but stepping into a market like China changes the rules entirely.
They have totally different requirements.
They often require specific bilingual labeling and unique registration identifiers printed directly on the physical packaging. Ensuring a single product label is compliant across North America, Europe, and Asia simultaneously is just a logistical nightmare.
Which perfectly explains why the guide points to the huge rise of e-labeling. Using QR codes or digital links for e-commerce contexts allows brands to maintain accurate, up-to-date compliance information without redesigning the physical box every time a minor regulation changes.
It's much more agile.
And it also directly ties into post-market surveillance. Brands are required to have systems to capture consumer feedback and adverse event reports after the product is purchased, ensuring they can take a rapid corrective action if some hidden issue arises.
And beyond the text on the label, there's the physical packaging itself and the massive industry push towards sustainability. Green chemistry is no longer just a buzzword. It's a strict regulatory expectation. Formulators are actively opting for safer solvents and cold processing methods that save immense amounts of electricity.
And regarding the packaging, the trend is shifting heavily toward monomaterial strategies. Because when a pump uses mixed materials, like a hard plastic shell with a little metal spring inside, it is nearly impossible for a consumer to actually recycle it.
Right, recycling facilities just reject them.
Exactly. Using a single type of plastic for the entire assembly fixes that. We're also seeing a huge rise in refill systems. But the text is very clear on one thing. You cannot just slap a little green leaf on the box and make eco-friendly promises anymore. You need hard proof.
Regulatory bodies are heavily cracking down on greenwashing. The source details the use of life cycle assessments, or LCAs. An LCA quantifies the actual environmental footprint of a product, from the harvesting of the raw materials, through the manufacturing, all the way to how it degrades in a landfill.
It tracks the entire lifespan.
Furthermore, there are frameworks like ISO 16128, which dictate exactly how natural or organic a product must be to legally claim those words on the front of the bottle. If you claim it's natural, you must have the mathematical formulation data to prove it.
The level of supply chain transparency is incredible, which leads us to the final and perhaps the most futuristic part of this guide.
If we connect this to the bigger picture, the integration of artificial intelligence and digital workflows is fundamentally transforming everything we have discussed so far. AI-assisted tools are accelerating formulation in ways that were pure science fiction a decade ago.
It's completely changing the game.
Machine learning models are being fed decades of historical stability testing data, so they can now screen thousands of ingredient combinations, predict how they will feel on the skin, and predict if the emulsion will separate before a chemist ever picks up a physical beaker.
They're using AI to find that perfect design space mathematically, drastically reducing the time and money wasted on failed physical experiments. But the concept I found completely fascinating was the mention of digital twins and knowledge graphs.
Oh, digital twins are incredible. A digital twin is a complete virtual simulation of a physical product. Formulators can run rapid prototyping and what-if analyses in a purely digital environment.
So they don't waste any actual materials.
Right. They can subject this virtual lotion to simulated extreme heat or test how it interacts with a virtual plastic bottle, observing the degradation without wasting a single drop of real chemical.
And then these knowledge graphs map out all the ingredient properties and interlink them with the labyrinth of global regulatory constraints we talked about. It's essentially a super intelligent digital assistant that knows every cosmetic law in the world.
Keeping everyone compliant automatically.
Right. Preventing a formulator from accidentally using a preservative that is totally legal in the US but heavily banned in Europe.
Now, navigating this digital frontier requires incredible cybersecurity, but it is unlocking unprecedented speed. Dr. Elena Rossi, a cosmetic formulation scientist quoted in the guide, frames this beautifully. She says safety and compliance aren't obstacles to be navigated, they are the foundations that unlock brand trust and sustainable growth.
To keep all of this virtual innovation tethered to physical reality, the text emphasizes that cross-functional teams rely on stage-gate checklists. At every major milestone, from the initial AI digital twin to the physical QC validation to the factory scale-up, teams from regulatory affairs, quality assurance, and supply chain all have to formally sign off.
It acts as a massive reality check.
Yes. It ensures that a brilliantly designed virtual product can actually be manufactured safely and legally in the real world.
It forces a seamless alignment between the limitless possibilities of digital design and the strict, unyielding laws of physics and government regulation.
So just to recap this incredible hidden journey, a product might start its life as an AI-optimized digital twin, existing only as data in a computer simulation. It then moves into the physical world where its formulation survives accelerated aging ovens at 40 degrees Celsius and is analyzed down to the molecule by HPLC sorting machines.
It's quite the gauntlet.
It survives the sheer force of scaling up from a beaker to a massive 10,000-gallon vat, constantly monitored by inline PAT sensors like a cake baking in an oven. And finally, it is placed in a recyclable monomaterial package with a globally compliant, digitally traceable label ready for you to take home.
This raises an important question to ponder. The next time you pick up a simple bottle of moisturizer, consider the invisible digital twin that lived and died in a simulation, just to ensure the physical lotion wouldn't separate in your cabinet.
It's kind of mind-blowing to think about.
It really is. As digital product passports become the standard, tracking every ingredient back to its source, how will this new level of extreme, unvarnished transparency change what you demand from the brands you invite into your daily routine?
That is a phenomenal thought to leave on. Thank you for joining us on this custom-tailored deep dive. We hope exploring this incredibly complex, high-tech world of cosmetic formulation has given you a profound new appreciation for the seemingly simple items sitting on your bathroom shelf. Keep questioning the hidden mechanics of the world around you, and we will catch you on the next deep dive.